on question 18 of some IGCSE paper, and it says that 0.4x with a big dot on it is a recurring decimal, so it means it's this 0.4x x, and x is a whole term such that it's between 1 and 9. Now we need to work out what it is as a fraction. So 0.4 as a fraction is 4/10, which is 2 over 5. So it's going to be more than that, and it's going to be somewhere between that and a half. But let's have a little look. So let's try doing it the way you would do a normal recurring fraction. So y equals 0.4 x, etc. So 10y equals 4.x, x. Let's try 100y. 100y equals 4x point x. So let's see what we can do with this, because I'm slightly puzzled, to be honest. 100y equals 4x point x, etc. 10y equals 4.x, etc. So that means that 90y equals, so we get rid of these x's there, and we get 4. Now, so that's going to be 36-ish. So let's pretend that's 40. So that's 36 plus x, because we don't really know what x is, and we're not going to find out, are we? So that's fine. So that means y equals 36 plus x over 90, which I suppose could be divided down into, divide that through by, that's 9 over, no, hold on. Divide that through by 9, so that's 4/10 plus x over 90. Which, let's be honest, we sort of knew it was going to be anyway, because it's between 4/10 and a half. So that is that. Now, what's the next question on this? A, B, C, E, D, yep. It's basically a house-looking thing. It's a rectangle, and CED is an equilateral triangle. AB equals x, so that's that, and BC equals y, and the perimeter is 100 centimetres, so we know that all of that equals that. The area is R. Oh, good Lord, show that the area is that. Right, well, this is fun. Let's see what we can do. So we've got, let's start over here. So we know this is, the perimeter is x plus 2y, but we don't know. Okay, let's try and work this out. We don't know anything about the height of that, do we? So, we know it's an equilateral triangle. Oh, that's right. So we know that this equals x, and this equals x, and this equals x. So that means that's 1, 2, 3x plus 2y equals 100 centimetres. Now, I'm tempted, I don't know which one will work, but I'm tempted to find y in terms of x, because then we can pop that into whatever we're doing, because this is all in terms of x. So we'll go 2y equals 100 minus 3x, and that means y equals, let's divide through by 2, so that's 50 minus 3 over 2x, or 1.5x. Okay, I'm just going to get rid of this line because it's just annoying. Right. Now, let's try another colour. So, what is the area going to be? So it's going to be R. So this bit here is going to be x times y. So that bit is going to be x times 50 minus 3 over 2x. And that equals 50x minus 3 over 2x squared. Okay, so that's one bit. Now, this bit at the top is going to be... so it's going to be... we've got to find out what this is to find out the area of that. So we're going to do half, and that's 1. So in order to get this, we've got to use Pythagoras. We're just going to use this here. So it's 1 squared minus half squared equals, and then square root it. So it's going to be 1 minus a quarter square rooted equals 3/4 square rooted, so it's root 3 over 2. So that's x over here is root 3 over 2. I shouldn't have used x, really, should I? And so the top, this bit here, is going to equal x times root 3 over 2x, which equals x squared root 3 over 2x squared. So, according to this, we have, so r is going to equal 50x minus 3 over 2x squared plus root 3 over 2x squared. Okay, it doesn't look that different from this, but it does still look quite different. So let's take the quarter, let's take the half outside. Or should we just times by... I tell you what I haven't done. I haven't times that by half. So it's half times base times height. So it's half. So that's got to be a root 3 over 4. So that's root 3 over 4. So if we did... if we took a quarter at the front, we'd get a quarter, and that would go up to 200x. And then that would go up to 6, because that would be minus 6x squared. And then that would be plus root 3x squared. Okay, so that's, do always remember to do its half base times height. Now, so that gives us a bit of something that looks like that. So let's take an x out of everything. So it's x over 4, let's do a big thing, 200 minus 6x plus root 3x. Now what they've done is they've taken the x out of that and made, and then made that plus. So that means we now do equals, it actually works out as that, 200 minus, and then that's 6, and then that's minus, because that's a plus, root 3, and then that's x. And that is how you do that.